guys, welcome to question MM432 of the Maths Methods Fortify study guide. So in this question we've got, over the school holidays, Swim Fun, the local pool, hosts activities for children each day such as water volleyball and water cricket. This program runs for the entirety of the holidays and children must choose one of these two activities each day. If a child plays water volleyball one day, the probability that they play water volleyball the next day is 1 in 6. If a child plays water cricket one day, the probability that they play water cricket the next day is 2 in 5. These probabilities apply to every child and are independent of the activity any other child is taking part in. That's actually really important. On the first Monday of the holidays, Justin chooses to play volleyball for the day. Find the probability that Justin also plays volleyball on at least one of the next 3 days. Awesome. So, if he plays volleyball at least once on the next 3 days, that means that we're talking about the probability that he doesn't play volleyball, and then we're minusing that. Okay, so we're doing 1 minus the probability that he doesn't play volleyball on any of the next 3 days. Okay, so what we're talking about is if he plays volleyball on the first day, and because we don't want him to play volleyball on any of the next days, because we're going to find that and then we're going to do 1 minus that. Because whenever we have at least 1, we can do 1 minus the probability of 0. Okay, so if he plays volleyball the first day, and he plays cricket the next day, and cricket the next day, and then cricket the next day, that's this probability here, and then we're going to do 1 minus that. Okay, so if he plays volleyball, the probability that he plays cricket the next day is 5 in 6. Okay, because the probability that he plays volleyball is 1 in 6. So 5 and 6 here. If he plays cricket the second day, the probability that he plays cricket the next day is 2 in 5. And because he's played cricket here, the probability that he plays cricket again is 2 in 5. Which means that our probability that he does at least 1 is equal to 1 minus the probability that he has 0, which is 5 in 6 times 2 in 5 times 2 in 5, which is 1 minus 20 over 150. Which is equal to 13 over 15. And this is our second mark. So our first mark actually comes when we do this and kind of recognize this here. And our second mark comes with our final answer, 13 on 15. Guys, that's it for part A. Let's move on to part B. So part B is a 2-mark question again. We're actually going to need to draw a proper tree diagram this time. So we've got our part B, which is 2 marks. And we know that Justin plays volleyball on the first day, right? It tells us that at the start of the question, which is a Monday, right? We're going to say that after that, on the Tuesday, he can either play volleyball or cricket. Then on the Wednesday, he can either play volleyball or cricket, and then volleyball or cricket, right? This is the Wednesday. Now, what we're trying to find is, given that Justin plays cricket on the first Wednesday of the holidays, find the probability that he played volleyball on the first Tuesday of the holidays. Awesome. So firstly, before we start even doing this, we need to figure out our probabilities and we need to fill in our tree diagram. So if he plays volleyball on the Monday, the probability that he plays volleyball on the Tuesday is 1 in 6. Which means that the probability that he plays cricket is 5 in 6, because these two have to add to 1 as always. Again, if he plays volleyball, the probability he plays volleyball the next day is 1 in 6, and so cricket is 5 in 6. If he plays cricket, the probability that he plays cricket the next day is 2 in 5. So that's a 2 in 5. And because these two have to add to 1, this is equal to 3 in 5. Awesome. That's our tree diagram taken care of. What we're looking for is the probability that he played volleyball on the first Tuesday, given that he played cricket on the first Wednesday, right? Which is the probability that he played volleyball on Tuesday intersect cricket on Wednesday over the probability that he played cricket on Wednesday. Awesome. So the intersect between volleyball on Tuesday and cricket on Wednesday is basically this pathway here. So whenever we talk about intersects with tree diagrams, we're talking about a pathway, right? So here our intersect would be our probability of this path, so 1 in 6 times 5 in 6, over the probability that he plays cricket on Wednesday, right? So again, 1 in 6 times 5 in 6, because we want, if he plays cricket on Wednesday, we're talking about this pathway and this pathway, right? So we got 1 in 6 times 5 in 6 plus 5 in 6 times 2 in 5. And this is going to be our probability. So this is our first mark up here as well. Now our second mark obviously comes from writing the correct answer, but let's just kind of work through this. So 1 on 6 times 5 on 6 is 5 in 36 over 5 in 36 plus 10 on 30. And then this is equal to 5 in 36 over 17 in 36, which is equal to 5 on 17. And that is our second and final mark for part B, guys. I know this is a bit confusing. Let me know if you have any questions about it and I'll answer them as quickly as possible. But otherwise, let's move on to part C. Part C is a 2-mark question and is a little tricky actually, but it's an interesting one. So part C, question 2 marks. Awesome. Now, what we're told is Justin discovers that Swim Fun isn't offering the cricket activity on the first day this time. That is, all children play volleyball on the first Monday. Okay, so this is the probability, or this is the tree diagram that relates to every single child, right? Because volleyball is the only choice on the Monday. There are 24 children in the holiday program. What is the probability that more than 16 of them play cricket on the first Wednesday of the holidays? All right, awesome. So we need to figure out the probability of any one of them playing cricket on the Wednesday of the holidays, which is, again, this path and this path. Okay, so they can play volleyball on the Tuesday and cricket on the Wednesday, or cricket on the Tuesday and cricket on the Wednesday. So the probability that cricket is played on the Wednesday by any child, regardless of this 24, we're not dealing with that yet, is 1 in 6 times 5 in 6 plus 5 in 6 times 2 in 5, right? Because it's this path and this path for the cricket on the Wednesday. This is equal to 17 on 36, which is our first mark. Now, we know that there's 24 children in the holiday program. We know that any one of them has a 17 in 36 chance to play cricket on the Wednesday. And so we're looking for the probability that more than 16 of them play cricket on the Wednesday, right? So what we do is we say, well, we've got this number of trials, we've got these independent attempts, we've got this same probability for each trial, which means we're going to be dealing with binomial. Okay, so we get out our binomial CDF calculator, and we say that, well, it's going to ask us for 4 things: upper, lower, upper, N, and P. Our lower is not 16, but 17. Okay, so 17, because it's greater than 16, so our lower has to be 17. Now upper is however many children we have, which is 24. N is the total number of trials, which in this case again is 24. And our P value is the probability that they play cricket on the Wednesday, which is 17 on 36. Now what this spits out is the probability that X is greater than 16 equals 0.0168. And that is our second mark. So that is it for part C. So this is a combination of the conditional probability and then using that probability in the binomial sense as a distribution there. Guys, if you have any questions about it, let me know. But for now, let's move on to part D. Part D is a 3-mark question and can be quite irritating to do. So, part D, 3 marks. And it says, Swim Fun has many locations around Melbourne and they want to estimate the proportion of children who play cricket on the first Wednesday of their holiday program. They survey 100 children to find out this information. For samples of size 100, P hat is the random variable of the distribution of sample proportions of children who play cricket on the first Wednesday of the holidays. Find probability that P hat is less than 0.48, given that P hat is greater than 0.39. Correct to 4 decimal places. Do not use a normal approximation. Cool. Well, first things first is, as I'm sure you've heard me say before in previous videos, whenever we have a probability that a P hat is something, whenever you see a P hat inside this probability, we want to change this P hat into an X value that we can use, okay? So we know that P hat is equal to X over N. In this case, P hat is 0.48. We don't know what our X value is yet, but we do know that our N value is 100, right? Because we've taken 100 children. We've surveyed 100 children. So our N is equal to 100. So that's 100. So therefore, X is equal to 48. Now in this case, I've got 0.39 equals X over 100. So X is equal to 39. All right. So that means that this is equal to the probability that X is less than 48, given that X is greater than 39. All right, so we've changed this p value, or p hat value, into an x value, which is exactly what we need, because once we do that, we can actually find the probability of the binomial distribution. So, because this is a given formula, what we're saying is that this is the probability of the intersect between these two things, which is the space between 39 and 48, over the probability that x is greater than 39. Awesome. Now, this is actually our first mark, finding that. Now we need to use our binomial CDF, okay? So we've got this, the probability that x is between 39 and 48. And remember, with our binomial CDF, we have our lower, upper, n, and p. Our lower is not 39, it's 40, right? Because it's not including 39, this less than. Upper is not 48, but 47, because again, it's not including 48. N is 100, because we have 100 students. And P is the chance that they play cricket on the first Wednesday of the holidays, which was 7 on 36, which we found before. So this is 7 on 36. Sorry, 17 on 36. That's a 17. And if your p-value here in your work solutions say 7 on 36, that's incorrect. It's meant to be 17 on 36. So that's our bad. Now, when we put this into our CAS, we get 0.4625, which is our probability of this bit here. So then to find our probability that x is greater than 39, we do the same thing. So we say that lower is equal to 40, upper is equal to 100 this time. We don't have an upper bound, so our natural upper bound is our 100. N is 100, and P is, again, 17 on 36. What this spits out is 0.9396. This is our second mark. And what we can then do is actually just plug these into our values, right? So we've got our 0.4625. So we have 0.4625 over 0.9396, and that's equal to 0.4922, and that is our third and final mark for part D, guys. And that actually wraps up MM432. So if you have any questions about any of this, please let me know in the comments below, as always, and thank you for watching, and I'll see you in the next video.